Hello students, so today we are going to start with double differentiation. So in this video we are going to study about double differentiation, how to do double differentiation, what is the meaning of double differentiation, and we are going to solve examples, questions on the double differentiation, and then after we're going to see what is the implementation, what is the use of double differentiation, that we are going to also see. Okay, so let's start ahead by understanding what is double differentiation. Okay, so if we take y equal to fx, okay, then you know first derivative, when we will differentiate for the first time, you will get dy by dx equal to f dash x, right? Now what if I differentiate it again? I differentiated this dy by dx with respect to x. Okay, so how can I write it? I can write d2y by dx square or y double dash, right? For first derivative I write y dash, and for second derivative I will write y double dash equal to or f double dash x. So this is the kind how I can write the double differentiation. Okay, that's all. Now how to do that? What is the meaning of double differentiation? So whatever function you are getting after first differentiation, you differentiate it again, and that we call as double differentiation. Okay, now let's see what is the meaning of double differentiation graphically. Okay, we are going to understand this thing. Now see here, I'm marking this point as A, and this point as B, and this point as C. Okay, if I ask you, this is the curve, this is your curve fx, okay, y equal to fx, okay, basically. Now this curve I am differentiating, right? So differentiation what gives me? Slope, right? Slope at that particular curve. So this tangent I drawn, this I am calling as theta 1, and this is theta 2, right? So I can say theta 1, tan theta 1 is only the slope, right? So if I want to calculate, now this is theta 1, so this is my slope, so this is my dy by dx. Okay, the tan theta 1 is my dy by dx at that A point. Okay, and at B point I can say dy by dx is, here slope is 0, right? And then after here it is tan theta 2, so tan theta 2 is positive and tan theta 1 is negative, right? You can see here, this is in second quadrant, right? Okay, now see, now what is the meaning? So what can I say here is that at point A, dy by dx is slope of tangent at point A, right? That is negative. So tan theta 1 is negative, so I can write it negative, right? And at point B I can say slope of tangent at point B. That's what dy by dx at B point is telling me, right? And that I can write 0, right? Slope is 0. What else? This is slope of tangent at point C, which I can say positive, right? Okay, now understand this thing. As my x is increasing, A have less x, right? Here x is low, here this point, this particular point, right? Here x is low, then x increase, and then x more increase. So now with increasing the x value, what is dy by dx is going on? Dy by dx first negative, then 0, then positive. Means when I am increasing the x value, dy by dx is also increasing. Okay, so here what is happening? Here what is happening? If I increase the x, dy by dx is also increasing, right? Okay, so what we can say is d2y by dx square is greater than 0. Okay, how I said this? Okay, if you remember in first derivative, when we said that if the first derivative is positive, then on increasing x, y will increase, right? That's what we said, right? While increasing x, y will increase if slope is positive. Okay, now also here I'm saying reversely. Okay, if x is increasing and dy by dx is increasing, then slope, the differentiation is positive. And reversely what we said in the first derivative, I will repeat here. Okay, what we said, if x increases and dy by dx is positive, then y will increase, right? And here what we are saying is, if this is increasing with respect to this, then the derivative of this. So here in place of y, what we did, we replaced with dy by dx. So dy by dx, here dy by dx of with respect to x differentiation. So that is greater than 0. So that's how. Okay. And don't worry, we will solve enough example, you will able to relate it and understand it. Don't worry about that. Okay. Let's see. Let's go ahead. Okay. Now see this note we have. Okay. So note, what note is saying me, he is explaining me the meaning of dy by dx and d2y by dx. Understand? If the function is y equal to fx, okay, then first derivative means y dash, okay, dy by dx. That tells me rate of change of y with respect to x. Okay, that I explained in previous video also, that how y is changing with respect to x. That is telling me the dy by dx. And second derivative is telling me how dy by dx is changing with respect to x. Okay, how dy by dx is changing with respect to x. If I increase the x, did the dy by dx is increased? Yes, then it is positive. d2y by dx square is positive. Okay. If I increase the x and dy by dx decrease, means d2y by dx square is negative. Here also I say, if I increase the x and y increased, then dy by dx is positive. Okay. That's what we say. Okay. And if I say that x increased and y got decreased, if I increase the x, y got decreased, then dy by dx is negative. The same thing we are seeing. Okay. Now, or we say rate of change of slope with respect to x. Okay, the same thing, same meaning. Okay. Now let's see with 3 examples. So in this case is similar to what we discussed here, right? Right. So you can observe here also. So here the slope is negative and the slope is 0 and the slope is positive, right? Here this, right? So with increasing x, dy by dx is increasing, right? So when it is going from negative, then 0, then positive, right? So what can I say? d2y by dx square is positive. Okay. Here what is happening? Here dy by, if I increase the x, there is no change in dy by dx. dy by dx is constant. Okay. And we know constant differentiation is 0. So d2y by dx square is 0. Okay. And here what can I say is, if I increase the x, how dy by dx is changing? See, here it is positive, less than 90, right? And then here it is 0, and then here it is greater than 90, right? So what can I say? dy by dx is going from positive, 0, negative. So positive to negative it is going, means decreasing. So dy by dx is decreasing. So what is the meaning of that? What can I say? d2y by dx square is less than 0. Okay. This is what. So if the curve is upward facing, then it is positive. d2y by dx square is positive. And if the curve is downward facing, then d2y by dx square is negative. Okay. That's all. And if the curve is a straight line, then second derivative will be 0, because first derivative will be constant. So second derivative came 0. Okay. Now let's solve some examples on that. Okay. And you will understand how to calculate the values of these things. Okay. So if y is given x square plus 2x plus 4, so y is given x square plus 2x plus 4. Okay. So what will be the y dash? So I will differentiate 2x plus 2. Okay. What will be y double dash x? So differentiation of 2x plus 2. Okay. That will be 2. Okay. Now what he asked? dy by dx at x equal to 1. Okay. So what will be the x equal to 1 you put in this function? So that way came 2 into 1 plus 2, right? So that is 4. If they ask d2y by dx square at x equal to 1, so we know d2y by dx is 2 only, so we will answer 2. Okay. It is not changing, it doesn't depend upon the x, right? It is a constant function. Now what happens is, some students make a mistake here. First he asks at x equal to 1, so they will put the x equal to 1, so they got dy by dx equal to 4. Okay. And then they will say that dy by dx is constant, so differentiation is 0. No, this you are calculating dy by dx at particular point. You see the function you see and differentiate the function. Okay. Don't differentiate it the value at particular point. See the function, how it is dependent, and then differentiate it. And then after whatever value they asked, on that you put the values. Okay, I hope this you understood. Now let's see next question. What is next question saying me? Y equal to 4x plus 3. So if y equal to 4x plus 3, then what can I say about y dash? Y dash will be 4 and y double dash x. Y double dash, what can I say? That will be 0. Okay, so from here at any particular point y dash will be same only and double dash will be 0 only, right? So that is my answer only at any point. So it is independent of x. Okay, that's all. Okay, that's all for this video. We'll see in the next video.